Next, we're going to look at how we can compare groups within our MANOVA. So remember that we have in our MANOVA, we have more than two groups. Now we want to look at how we can use contrasts to compare different groups to one another, or even other linear combinations of groups. So a MANOVA with only two groups, and it's Wilks lambda, or its Bligh's trace, or its Roy's greatest root, or any of those statistics, turn out to be equivalent to an independent sample t-squared test. That provides us with a framework for doing follow-up comparisons involving linear comparisons, including pairwise comparisons, and this is very similar to what we have learned in univariate ANOVA, where we use contrasts to do pairwise comparisons between groups, and then get t-tests. So essentially what we're doing here is t-squared tests. The main difference is that if we just did pairwise t-squared, we would be leaving the third or more groups out of the W matrix. But W is just the within group SSCP, and because we're assuming equal covariances, we're also assuming that the W matrix is going to be the same for each group. Remember, W is an unbiased estimator of the population SSCP. So it's sort of senseless not to use it. It's giving us a better, including every group in the W matrix is going to give us a better estimate of the population covariance matrix. So instead of directly doing t-squared, what we can do is just in principle, subset our data with just the two groups of interest and then use that B, but use the same W that we got before. So if we wanted to compare the group that saw A New Hope to the group that saw The Force Awakens, the only change we would need to make is we would need to create a new B matrix based on only these two groups. So I'm going to use the same B data that I created in the last last set of slides, except I'm deleting rows for the Phantom Menace. So just as a reminder, the B matrix it replaces every row of data with just the group mean or the group mean vector in the MANOVA case. So here I'm just deleting every row that was the Phantom Menace. So now I only have a data set that's contains the observations for the New Hope and Force Awakens, with the mean vectors replacing the actual observations for each group. So now I can get my B matrix from my subset data, and then I can get lambda just the same way I did before, using the same W that I'd created previously, which was just the W matrix from the full data set. So I get my B matrix, and then I plug that into my lambda calculation, which is just the ratio of the determinant of W to the determinant of W plus B, and that gives me my lambda statistic. So for this test, I have to decide which F approximation I'm going to use. And so here I'm going to use the P greater than 1, G equals 2 case, because I have two groups from table 6.3. It actually turns out that this F is very slightly different from what R is going to give me when I just do this the easy way in R, but this is pretty close, and lambda is going to be the same as what we're going to get from R. So here I get my F value and my P value, and again, it's a large F value, so I conclude that there is a significant difference. And for reference, here's table 6.3 again. So I was using the P greater than 1, G equals 2 case, which is the third row here, to get my F approximation. So another way to think about this, and this is how this is going to work in R, is what we're really doing is we're testing a linear combination of groups. So in this case, I was testing 1 times A New Hope plus 0 times Phantom Menace equals 1 times Force Awakens. So I'm dropping Phantom Menace just by zeroing it out, and I'm testing A New Hope equals Force Awakens. And you can rewrite this as 1 times A New Hope plus 0 times Phantom Menace minus 1 times Force Awakens equals 0. And this is how we're going to test our contrasts. And we can do any linear combination of our 3 different groups this way, using these contrasts. And this is how we're going to set it up when we do it in R, which is obviously easier than calculating all these matrices by hand. So one thing is that R gets a little funky or does some weird stuff. It's a little bit different than some other software when we want to directly compare 2 groups. And it took me a little while to sort of figure out how to do this in R. I knew how to do it, learned how to do it in SAS before, but to figure out the automatic way to get these contrasts was a little bit roundabout. So the trick is we have to redo the model, but we actually have to suppress the intercept. So the R output doesn't give us the intercept by default, but we can ask for it. We get the MANOVA model output. There's an argument that you can set to true that will give you the intercept. But what we need to do is suppress it. And what that's going to do is it's going to give us 3 different coefficients that are going to give us the value for each of our 3 groups, as opposed to having an intercept and then having some kind of contrast which compare 2 of the groups to the intercept and have the intercept sort of represent the 3rd group. So to suppress the intercept, we're just going to add 0 plus to the beginning of our formula syntax. We don't want to interpret this model directly because it would be sort of confusing to interpret the actual results of this model, but we can use it to test our contrasts. The model we want to interpret is the one that includes the intercept. So now we can specify some linear contrasts for any hypothesis we want to test, including pairwise contrast, with this linear hypothesis function, which is also from the CAR package. So just as a refresher, we have to keep this in mind that the order of the levels defaults to alphabetical. So the first level is Force Awakens, the second level is New Hope, third level is Phantom Menace, which is slightly different from the order in our data, just that R treats any factor as alphabetically ordered by default. So if we want to compare Force Awakens to New Hope, we need to compare the first group to the second group. And so we would do that like this. So we would we would call the linear hypothesis function on our MANOVA with the suppressed intercept, and then for the hypothesis matrix, we would specify some linear combination of our 3 variables. And so this is going to give us a fairly large output, similar to what we saw with the capital M MANOVA output. But this is a little bit smaller than we saw before, so it does fit on a screenshot. So here's a screenshot of the full output. So you see we get our sums of squares for the hypothesis. This is the sort of faux B that we created before, just comparing the 2 variables. And then we get the sums of squares for error, which is sums of squares within. And then we get our test statistics, and so you see we get all 4 of them, but note that the Wilks statistic matches up to the Wilks value I got before, but although the F value is very slightly different. So here we say there was significant difference in people's opinions about Force Awakens and Phantom Menace simultaneously on entertainment value, writing quality, and action. Wilks lambda equals 0.53, F of 3262 is 78.78, P less than 0.01. And so this was a very slightly different F value than what I got when I did it manually, but the lambda is the same. So it's really just the transformation from lambda to F that was a little bit different here. Of course, if we wanted to compare the Force Awakens to Phantom Menace is a 3rd variable, we can do this contrast. And here's that output. And then the 3rd comparison, if we wanted to compare A New Hope or to the Phantom Menace, this is the last pairwise comparison we can do. We just do it this way with this contrast matrix, and then we get this output.